This is the last of the logarithm laws. So this is logarithm law number 3, and a very, very useful law at that. So this law states that if we take the logarithm of an exponential, so log base a of x to the power of n, okay, the n, okay, in the exponential moves out to the front of the logarithm. So what the logarithm does is that it turns it into a product. Okay, so you have a product of the index n times the logarithm base a of x. So an example would be log base 2 of 8 to the power of 3. The 3 moves out to the front and it turns into a product of 3 times log base 2 of 8. Okay, so 3 log base 2 of 8, well, the log base 2 of 8 is equal to 3, okay, and we're multiplying it by 3, so that gives you 9. 8 to the power of 3 is in fact 512, and 2 to the power of 9 will give you 512. So this does work, at least in this particular example. So let's now prove it generally. Okay, so we're going to do something, again, somewhat like what we've done in proving logarithm law numbers 1 and 2. So what we're going to do is we're going to let x equal a to the power of m, for example. Okay, so you can do this many ways, but probably easier to use the convention that we've used so far. Okay, then what we have then, if we raise both to the power of n, okay, so x to the power of n then is equal to a to the power of m all to the power of n. Okay, and that's equal to a to the power of m times n. That's index law number 3, right? The power to a power law. So if you have a power and you raise it to another power, you multiply the two powers together. Okay. So if x is equal to a to the power of m, okay, if we take the logarithm of that, okay, so converting this into logarithm form, log base a of x is equal to m. Okay. Now from this side here, okay, log base a of x to the n, okay, is equal to mn. After all, a to the power of m times n, okay, gives you x to the power of n. Okay. But we have a definition for m, okay, so this is very important, what we just came up with there, okay. So hence log base a of x to the n is equal to, I'm just going to reverse the n and the m, okay, but we know what m is. M is log base a of x. Therefore, log base a of x to the n is equal to n times log base a of x as required.